Yeah. So good evening, everyone. In the last videos, just we started a new batch. Okay, just we started a new batch on data structures and algorithms with Java. Okay, last class we started a new batch on data structures and algorithms with Java. Okay, let me provide that course information. Okay, and we will start our session. You can see in the last videos, I explained about the syllabus, what we are going to cover in this course. At the same time, what is your actual plan of these classes in detail, I explain. If you see, the title of the course is nothing but data structures and algorithms with Java. So I told it is the seventh batch. Successfully, we completed all the six batches. It is the seventh batch and it is an add-on batch. Add-on batch means what? Already we announced one batch. It is going on. Just for that, additionally, we are going to take some demos and we are going to club with this batch. Okay. Sir, the fees for this batch is rupees 1500. The duration of the course is 2 months. Okay. So in these 2 months, September and October, we will close this syllabus. And the actual duration of this course is nothing but 2 months. But the timings of the class is not at 10 o'clock, sir. The timings of the class is from 9:15 p.m. to 10:30 p.m. Okay, from Monday onwards. That means coming Monday onwards, our class timings will be 9:15 p.m. to 10:30 p.m. Again, I am reminding you people, please make sure that your time, available time, you have to make it as a free from 9:15 to 10:30. Okay, but this week demos will be there from 10 p.m. to 11 p.m. And if you are okay with this, you can contact to this number and get registered. Already some people registered for that course. Now coming to the demos, total 4 demos will be there. Yesterday we have taken one demo and today is the second demo. And the content what we are going to provide is, you will get running notes access. At the same time, we are preparing some interview questions also on these data structures, and we will provide for you that PDF, and videos access also will be given for 6 months. And prerequisite for this is nothing but core Java must be required. Okay, and this is our old batch videos, not all the videos. Old batch demo videos are there here. Okay, so old batch demo videos are there in this YouTube. So if you want our new batch means, so current batch demo videos, if you want, we have playlist is there. Just I will share that playlist YouTube link so that you can able to refer. But as of now, this is nothing but old batch videos link which is there in our YouTube channel. So yesterday we have taken one session, so that demo is also there in our YouTube channel. Just a second, I will share it. So you can see data structures and algorithms 10 p.m. So yesterday we have taken this class, but today also this video will be uploaded in this. Okay, this is nothing but old batch videos and a new batch videos, both I am sharing for your reference purpose. Then I explained about the syllabus what we are going to cover. So first three chapters are going to provide only introduction. Programming won't be there in depth. So introduction to data structures, algorithms, what are the different types of algorithms that are existed. Next, and after that, analysis part, like how you are going to calculate time and space complexities. Then third chapter, like how to implement some sample algorithms. These three chapters are going to give introduction to our course. At the same time, you are going to get some just a refreshment of this Java. Whatever concepts that you have learned in Java, just we are going to refresh that. That's all. Beyond that, nothing. And from array, our actual content is going to be started. I explained very clearly about the syllabus, all these things. But today, already yesterday, we started the third chapter, which is nothing but some sample algorithms and implementation of those algorithms we started. As a part of that, first I explained the program to find out addition of two numbers, right? Already we implemented. How to prepare a Java program, I explained first. Then later I implemented one simple method to perform addition of two numbers. And from the main method, we invoked this business logic and we evaluated, we tested the program is working fine. Okay. Now in today's session, I will go with the second program what we have. What is the second program, sir? We have to implement a program to check whether the given number is even number or odd. Okay. So we have two methods are there to solve this problem. Anyway, to explain this, I am going for IntelliJ IDEA to do the programs. Okay. I am taking IntelliJ IDEA editor to do these programs. Let us see how it will be, how it is going to work. Okay. Now just have a look once. How to prepare a sample program in this IntelliJ IDEA? As usual, how we have written our normal code in the same style we have to take. So assume I have main program is there. Okay, assume I have main program is there like this. This is nothing but my main program. See, I want to print some message on the screen. Okay, I want to print some message on the screen. How to do that? So very simple. Just we are going to take system.out.println. Okay, we know that format, right? System.out.println of just we are going to print. So hi again, some message I am printing here. So if I execute this particular program, we are going to get this output on the screen. A simple Java program. Public class main, public static void main. This is the main program, sir. And if you click, what will happen? If you run the file, you can see we are going to get the output on the console saying hello again. This is the way how to execute a simple program in this particular IntelliJ IDEA. Now, what is our task here? We have to implement a program to check whether the given number is even or odd. We have multiple ways are there. For example, I am taking system.out.println of so method one I am taking where I will pass a number, something like 5. So we have to check whether 5 is an even number or odd number. Okay. And even, so I am going to pass a 6. So since 5 is an odd number, I am expecting output as a odd. Since 6 is a even number, I am expecting output as a even. So what we have to do? We need to define one public static method, but the return type of that method is a string. The name of the method is method 1, which is going to take one integer variable n. So what we have to do? We need to write a logic such that that particular logic should return so even when the given number is even, and that logic should return odd if that given number is odd. Like that we have to implement the program. So I think you know the logic very clearly, right? So I'm using conditional operator. So I will check a condition. If that condition is true, I will return the message saying even. If the condition is false, I will return odd. Sir, what condition we have to take? Array can I will divide that number with the two, sir. So if really it is divisible, I am going to print even. I am going to return even. Otherwise, I am going to return odd. A simple code I have taken. Now listen carefully. Suppose if the given number is n is equal to something like 5. Is 5 is divisible by 2? Yes, sir. So 2 2s are 4, remainder is 1. So it is not divisible. Means what? It is going to return odd. And if n is equal to 6, so is that 6 is divisible with the 2? Yes, sir. 2 3s are 6, remainder is 0. So immediately we are going to get even. Like this we will get. If you are having doubt, just let me run this code and cross check whether really we are getting that odd and even or not. You can see we are getting odd and even. See, I want to write a loop. That loop is going to generate the numbers from 1 to 10. Every number I want to check whether it is even or odd. What do we have to do? Just we have to pass the value of n as the input. That's all. So automatically it is going to check whether it is even number or odd number. Now observe carefully. The list of values I will get or not. Yes, you can see even, odd, something like this we are getting. Sir, in addition to that, I want that number also. No problem. Try to print the number and give some tab space and print the result. Just I am refreshing the code. You can see every number and the corresponding result you are going to get. Is 0 is the even number or not? Yes. Is 1 is odd number or not? Yes. 2 is even number. 3 is odd number. 4 is even number. Like that we are getting. So please confirm, are you clear with this first approach, whatever I explained up to this? Yes, please
Yes,
confirm.
sir.
Yes, yes.
Yes, sir.
I need response from everyone, sir. Please confirm. Right. Now, see, there is one more way is there to perform this even number, odd number calculation that you have to tell. What is that way is, see, I want to represent the number 0 in binary digits. I will take 4-bit representation. If you are taking all 4 bits as a 0, I can say it is nothing but zeros like this will be there. So I want to represent the number called 1. What we can able to do? 0001 like this I will take. If you take 2, 0010, something like 8421 code. If you take 3, so 8421, by adding 2 and 1 we are getting 3. If you take 4, so 8421 like this. If you take 5, so 8421 like this. If you take 6, so 8421 like this. If you take 7, so 8421 like this. If you take 8, so 8421 like this. If you take 9, so 9, then I'm going to take 8421 like this. Like this, if you take 10, so 8 plus 2 like this. Sir, if you observe here, we can identify some concept. Like I'm implementing by bitwise operators to check whether the given number is even or odd. Can you please see this particular pattern of binary numbers from 1 to 0 to 10? And can you please tell me what observation that you have made for the even numbers and for the odd numbers? So are you identifying any special notification here? Can you please confirm? So which numbers are odd, which numbers are even? Do you notice any special cases here? Hmm. Please respond.
In even numbers, in the end we have 0. In odd, we have 1.
Very good, very good, very good. Excellent. See, if you see, sir, please understand, 5 minutes class is very, very important. Please focus. Please focus. Have a look once. See, if you take all even numbers are having the last bit as a 0. I'm going to represent the last bit as least significant bit, LSB. Okay. So if least significant bit is 0, then it is even number. And if your least significant bit is 1, I can say it is nothing but odd number. Means what? Please listen. For odd number, last bit will be always 0. Sorry, always 1. So for odd number, last bit will be always 1, sir. Okay. Now keeping that in mind, so 1 means what can I say? Is it like this? Yes. 1 means it is something like this. Now you can take any number. You can take any number. For example, I am taking 3. What is its binary equivalent? So 0011. So I want to make this one as a dummy and this one as a dummy. That's why I am performing AND operation. 0 and 0, 0, 0 and 0, 0, 0 and 1, we will get 0. 1 and 1, 1. What is the result? 1. So if you are getting 1, I can say it is nothing but odd number. Suppose if you take this 6, what is its decimal equivalent, sir? Binary equivalent? 0, 1, 1, 0. Now try to perform AND operation with 1. Why you are performing AND operation only with 1? Because for 1 only, we will get least significant bit as a 1, and remaining things will become 0. That's why while performing AND operation, we are focusing on only least significant bit. Rest of the things will be automatically converted into 0, sir. Okay. Now you can see. So 0 and 0, 0, 0, 0. Definitely, because here we have fixed the result. 0 or 0 and 1, sir. What output we will get? 0. If you are getting 0, can I say is it even number? Yes. So now finally the logic is whatever number that they have given, try to perform AND operation with 1. If your result is 0, I can say it is nothing but even number. And if your result is 1, then I can say it is nothing but odd number. Sir, it is something like n percentage 2 only. If it is 0, we will get even number. If it is 1, I am going to get odd number. Then what is the difference? It is going to take some less time when compared with this AND operator. So these are because it is a bitwise operator, which is going to take less time to evaluate. It will take some more time when compared with bitwise operators. So this is nothing but the second logic what we have to check whether the given number is even number or odd number. Anyway, this application again I will explain in the bit manipulations chapter. We have a chapter is there with name bit manipulations. There in depth I will explain. But as of now, look at top level how I implemented this code to generate that formula. Is it clear for you people? Please confirm everyone. Yes, please confirm everyone. Clear up to this?
Yes, sir.
Right. So this is nothing but what we have here. Now I will implement this code, sir, because already we implemented only one method. See, parallelly, I will check by taking method 2 also. Okay, by taking method 2 also, I want to check. Now let us define method 2. Sir, same signatures I will take. Public static, the return type is a string only, and method 2, which will take one integer data. How to apply, sir? Just I am taking return. Here I will take n percentage, sorry, n ampersand 1. If your result is 0, then I am going to return the message saying even. Otherwise, I will return the message saying odd. Simple code, sir. We are performing AND operation. Okay, AND operation with bitwise operator. Okay, AND operation with 1. If your result is 0, then I will return even. Otherwise, I am going to return odd. If my logic is clear, I should get the same output for the first one and second one, right? For first method and second method, same output should be there. Let me cross check. I am going to run the code. So you can see we are going to get a tabular column. So where you can see the 0th number is nothing but even, and this one is odd, maybe space adjustment, no issues at all. So next one even, odd, even, odd, even, odd, even, odd, even, like that we are getting. I think you understood how we are going to implement a program to check even number or odd number application. Sir, are you clear with these both logics, whatever we covered? Please confirm.
Yes, sir.
Yes.
Yes, sir.
Right. So before moving to the next program, anyway, if I'm taking only programs, maybe you people are going to get bored. That's why I'm going to take one real time problem. So of course, not a program, sir, just at a top level. Why? Two ways to solve. We have to solve the problem in multiple ways, madam. Okay, we have to solve the problem in multiple ways. But among those ways, we are going to fetch the best result, best way. So among these two ways, we have implemented by using method 1 and method 2. Among these two, which is going to execute very fastly? Now I have executed, right? Yes, sir. Sekar. Yes, sir. So second one is going to give the best result. Why? So I told bitwise operators are going to evaluate fast when compared with normal arithmetic operators. So, but we have an option. We can do this in both ways. If an efficient person is going to use the second way, got it?
Sir, when we say efficient, then
Hmm.
the efficiency is time complexity,
Yes,
memory.
with respect to time and space only.
Yeah, but this, for all the things there is a for loop, right? So it will be O of
Yes,
n
yes. Yes,
for
it is a
both the two.
yes. For everything, we are going to measure with the help of input size all these things. So here we are not going to run any loop. It will take unit amount of time. It is also going to take unit amount of time. Why? Because it is a single instruction, right? So both are going to take the same time theoretically. But when we are executing inside the mission, definitely bitwise operators are having more priority when compared with these operators. Okay, got it?
Yes, got it. Yeah,
The
but O
reason
of
you know,
one,
yeah, O of one, both are
one
O of
only.
one.
Okay.
Whenever you are not having any loops, blindly you can select it is O of one.
Yes. Okay. Thank you.
Mhm. That we will see, madam. In the second chapter, I will explain. Now, sir, I think you know about one concept is there with name recursion. So anyone having idea about recursion, definition of recursion? Can you please tell me what is recursion? Anyone having idea?
Repetition of same code.
Repetition of same code. Good.
Method which
So
called itself.
yes, which calls itself. Can I say a method or a function which is going to call itself is called as a recursion? Can I use that word? A recursion is nothing but what? A method or a function which is going to execute, which is going to call itself. The method which is called by itself is called as a recursion. Okay, a method or a function, so which calls itself. Okay, which called itself, which calls itself is called as recursion. See, based on this recursion, we have multiple examples are there. Multiple examples we are going to do with the help of recursion. See, I will show you at a practical. If you see any application, suppose consider here I have one static method is there with the name yum. So generally what will happen? System.out.println, I am printing a message saying hello. So now I want to call this method. How to call? Simply we will see. If you see, the control is going from this place to this place, and it is started executing. Once the task is completed, it will come back. How the method call is going to be maintained? They are going to maintain internally one stack data structure will be maintained. So program execution always starts from main method, and the main method is going to call some other method, which is nothing but yum. Once if the yum method execution got completed, so system automatically deletes this entry from the stack, and it will return whatever result yum is calculated to the main. And main will be deleted, and it will return whatever we are going to get in the form of outputs. This is the thing which is internally happening. Okay. So please confirm. Is this method call process? Is it clear? How these method calls will be maintained? Is it clear?
Yes, sir.
Yes, sir.
Yes.
Right,
Yes, sir.
right. Now what I'm doing is I want to make it as a recursion. So what we are going to do here, we are going to print the message. After that, again I am calling yum. So now please observe what will happen in this stack entry. What will happen? Sir, first we are going to call main. First, we are going to call main. And main is going to call some function called m. So this m is again calling m. This m is again calling m. So this m is again calling m. Is it never ending process or not? Sometimes
Yes,
this
sir.
stack is going to overflow. This stack is going to overflow. Okay, immediately it is going to stop. Immediately it is going to stop executing, because a stack is an internal data structure which is associated with some small memory. Because of that, what will happen? You are going to get infinite execution. Maybe abnormal behavior you are going to get. You can see infinite times it is printing. Have you observed how many times we got hello? At the last, you can see one message. What is that message? Sir, I am unable to capture. Yes, you can see. Sir, what error message it is printing? Is it possible for us to understand this message? Let me see. Have you observed? Are you seeing here stack overflow error? Stack overflow error. Internally, it is maintaining one stack. That stack got overflowed. That's why we are getting a problem. Okay. This is called as a finite recursion. Sir, infinite recursion. Can I make this as a finite? Yes. You can give some number here. Array, I want to execute only 5 times. Sir, now observe carefully. Here we are going to receive one number. If that number is equal to 1, can you please stop the process? Return means immediately it will terminate the function. Immediately it will terminate the function. Now, what I'm going to do is just I'm going to print the message called hello, and I'm printing n minus 1. Please look carefully. So what will happen here? What will happen here? Sir, first time we are giving the value of n is equal to 5. Then the control is going here. The value of n is 5. Is n is equal to 1? No, it will print the message called hello. Then we are calling the same function by passing n minus 1. N value is previously 5. 5 minus 1 means 4. Is it equal to 1? No. Again, it will print the message called hello. Again, it will be called by passing 4 minus 1, 3. Now, what will happen? It will print the message called hello. Now, again, it will be called for 2. It will print the message called hello. Again, it will be called for 1. It will print a message called hello. Now, it will be called for whenever we are getting 1. So, or whenever we are getting 0, we are going to stop. What will happen next time when we are giving 0? It will stop. How many times we got a hello message? Is it 5 times or not? Because we have given the condition saying I need to execute 5 times. Sir, this is nothing but a simple concept what recursion is going to do. The people who understood this problem, no issue. The people who are not understood this particular problem, just leave it, sir. At the top level, try to concentrate, because we have a recursion chapter is there. There I will explain these things with multiple examples, with beautiful things, so that you can able to understand very clearly. Just now, as of now, for the demo purpose, I am explaining these. So in detail in our upcoming classes, we will see. Now, I want to cross check really is this output is coming for this program or not. Just let me cross check. So I will execute this code. Have you observed? We are getting hello message. How many times? 5 times. Sir, are you clear with this recursion concept? N is equal to n minus 1. See, this n colon is maintained by this IntelliJ idea. Okay, that is not a part of program. So it is taking the parameter name. So here, what is the parameter name? N, right? That's why it is taking n colon. That means we are supplying the n value like that. Yeah, no problem. It is a part of IntelliJ idea code. Can you please confirm everyone, is the concept whatever I covered, is it clear for you people?
Yes, sir.
Yes, sir.
No doubts, right? Because slowly I am converting into one application. That's what I am asking. Are you clear with this?
Yes, sir.
Can I go for next application from this?
Yes.
Yes.
Right. Now,
Yes, sir.
now see what will happen. See, I'm going to develop one small application. I don't want to print hello. I don't want to print hello. I want to print n val. I want to print n val. Now see what output we are getting. Sir, what output we are getting? 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. In the reverse order, we are getting the numbers. In the reverse order, we are getting the numbers. What is the first n value that you have passed? 5. So what output we got? Sir, we are getting 5, 4, 3, 2, 1. Like this we are getting. Sir, I don't want this 5 to 5, 4, 3, 2, 1. If you are passing n is equal to 5, I want to get 1, 2, 3, 4, 5. Is it possible by using recursion? Yes, both are possible. Can I say wherever reverse concept is coming into the picture, wherever reverse concept is coming into the picture, there I can use recursion concept or not? Can you please give confirmation?
Yes, sir.
Wherever left to right movement, right to left movement is required, can I take recursion? Please confirm with this knowledge.
Sorry, what left to right?
Suppose I have some numbers are there, like 1, 2, 3. I want to move from first number to last number, or I want to move from last number to first number, or I have a string is there. I have to start visiting each and every character from the beginning to ending, or from ending to beginning. So, like,
Yes, sir.
is it
It's
possible?
possible.
It is possible to move in this direction by using recursion.
Yes, sir.
Yes, sir.
Definitely possible, right?
Yes, sir.
Now, observe carefully. Observe carefully. I'm going to write one small application, sir. Okay, I'm going to write one small application so that you will get a clarity how it is going to work. Now, please listen carefully. See here, I'm taking this system.out.println after this. After this. Now listen carefully. What output we are going to get. So what is the output that we are getting here is, sir, 5, 4, 3, 2, 1. Again 1, 2, 3, 4, 5. This is what I am trying to explain from the past 5 minutes. See, it will maintain one stack, I told. First, we are passing n is equal to 5. Here it came. Is your n value is equal to 0? No. It will print n value. The output is 5. Then what will happen? That method call will be registered or not? Like, definitely. Now from this, we are calling a method by passing 5 minus 4, which 5 minus 1, which is nothing but 4. Next time your n value is 4. Is it equal to 0? No, it will print the 4. Next time what will happen? We are calling 4 minus 1, which is nothing but 3. It is printing the content. And next time what will happen? It is going to call the method by passing 2. So next time what will happen? We are calling the method by passing 1. It will print. Next time what will happen? We are calling the method by passing 0. So whenever we are passing 0, immediately it is terminated, return. Sir, maximum students are going to feel because of this return statement, the function is going to come out. We won't execute any task after return. No, that is not possible. You have to check this code executed, this code executed, this code is also executed. But if you see, this statement never executed till now. How many times this recursion is made? Those many times this print statement will work, sir. Please listen carefully. How it is going to work? Sir, do you know whenever 0 is there, it is terminated. This entry will be deleted and it will come back. M is equal to 1. What is the n value at that point? 1. It will delete. Next time it will come here. What is the n value at that point? 2. It will delete. It will come. So what is the n value? 3. It will delete. It will come. What is the n value? 4. It will delete this entry. It will come. What is the n value? 5. So it will delete. It will come. Then the program is going to stop. Sir, whatever movement that we have taken in this direction, it is called as a recursion. And whatever movement that you have taken in this direction, it is called as backtrack. Okay, it is called as backtracking. I think maybe theoretically you understood the concept, sir. Right? Please confirm everyone.
Yes, sir.
Yes, got it.
Got it? So my intention to explain this entire story is nothing but to demonstrate one real-time example problem. Okay, like you can take Sudoku or N queens. These problems are okay. After written, I didn't understood. Ayo. After written, this is nothing but recursion call. Okay, I will explain later, Shekhar. Don't get confused. Just to see at the top level because it is not that much important now. See, it is a demo, right? Just please concentrate on way of my style of teaching all these things. Okay, right. Now observe carefully. I want to demonstrate one concept for you people. What is that concept is, sir, can I say applications of recursion? Applications of recursion. Can I say method calls? Method calls will be done by using recursion. Can I say reverse calculations, reverse of a string, reverse of a number, okay, reversing the linked list, reversing the linked list. Okay, everything is possible by using this. Even decimal to binary conversion, decimal to octal conversion, decimal to hexadecimal conversion, like we can do decimal to binary conversion, we can do by using this recursion. Okay, so next and after that, even permutations, combinations, problems, like we have so many examples are there which can be solved by using recursion. So recursion with backtracking, I'm going to explain n queens problem now. Okay, just a problem statement alone I will provide, sir, so that at least you can understand so how we are going to implement this problem in the future. Sir, what is this n queens problem? So n queens problem is a very simple problem where we are going to have a chessboard. We are going to have a chessboard like this. So with 8 rows and 8 columns. I think you know about chessboard, right? So chessboard is having some special coins will be there, and we have some elements will be there and some rules and regulations. So we have to move the position of that particular coin in only one direction. Like that, we have so much of stuff is there. But as of now, for our understanding purpose, I want to go for 8 by 8. I will go with 4 by 4. Please remember carefully. I have a 4 by 4 chessboard is there. So 4 by 4 chessboard means 4 rows will be there and 4 columns will be there. Please concentrate well. These are nothing but 4 rows and these are nothing but 4 columns. Like that, I have a 4 by 4 chessboard is there. Like this I have. Please remember, friends, I'm going to explain how you can able to solve this chessboard. See, the target is here in this 4 by 4 chessboard. In this 4 by 4 chessboard, we have to place a queen. Queen means what? In our terminology, some people are going to use the word called minister, minister, something like that. See, what is the possible directions for the minister? The minister can move in any direction. Okay, right? I think you know very well. The king can make only one step, but a minister can make any number of steps, and in any direction the king can able to move. Suppose consider we have a queen. We are calling that king as a here queen. Queen is there. So we have to place the queens in this chessboard. Since it is a 4 by 4 chessboard, we have 4 queens are there. Okay, we have 4 queens are there. That's why it is called as n queens. What is my task is, you have to place the queens in each and every row. In first row, we have to place the first queen. Okay. In the second row, one queen. In the third row, one queen. Per row, one queen we have to place. So there are some rules. No two queens should collide with each other. If you take a queen here, that queen can move in this direction, in this direction, in this direction, in this direction. In the diagonal direction also, this queen can able to move. So while moving in this direction, no two queens should collide with each other. That is the property. Can I take a queen here? No collision will happen. Can I take here? Yes. 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 Like that, we have to take. So by moving the queens in these positions, no two queens should collide with each other. Like that, we have to arrange the queens. This is the problem what we have. Sir, is the problem statement is clear? Don't worry, sir. The people who are unable to understand, please concentrate my way of teaching and just at the top level. Okay, because in detail we are going to discuss in our recursion and backtracking. Okay, but only two queens in a chessboard. No, I will explain. Just I'm asking about the concept. We have to take four queens. Since it is a 4x4 chessboard, we have to take four queens. We need to arrange each and every queen in a row. First row one queen, second row one queen, third row one queen, fourth row one queen, such that no two queens should collide with each other. Are you getting problem statement, Saurabh? I will explain. I will put all the queens and I will show you the solution. Is the concept is clear, friends? Please confirm. Everyone, sir, please.
Yes, sir.
Right. Now observe carefully. I am going to give solution for this. How you can able to place the queens? We have to check. And please make your mic as a tool, and or you can use chess. You can use chart window, and please give answers to my questions. Sir, I am taking the first queen in the first row. I have placed the queen here. Now I am trying to place the second queen. Can I place in the first position? Please confirm. Can I take here?
No.
No. Can I take here?
No.
No. Can I take here?
Yes.
Yes. Because there is no collision. Now I am going for third row. Can I take here?
No.
Can I take here?
No.
Can I take here?
No.
No.
Can I take here?
No.
So now I started placing the first queen. I started placing the second queen. When I am placing third queen, can I say there is no room for the third queen, right? So now what I am doing is I will go for backward, something like backtracking. So where I placed the second queen, I placed it in the third position. Can you please shift this position to fourth position and try all possible combinations again? Now we are taking here. Not possible because collision. Can I take here now? Yes, happily.
Yes.
Yes.
Can I take queen here?
No.
Fourth
No.
queen? No. Can I take here?
No.
No.
No. Can I take here?
No.
No. Can I take here?
No.
Can I say fourth queen is not having any possibility? Now tell me which queen we have to change the position now. Please confirm.
No. For now, 13, I think.
First.
Which node? Which node? Which queen we have? Sir, please be on mute. Some disturbance is coming.
Row first column.
Yeah. So which queen is latest placed? That queen we have to disturb. Sir, I placed third row here, right? Now can I take here? No, possibility is not there. Can I take here? No. So in the fourth row, no possibility. In the third row, no possibility. In the second row, also all possible combinations we have tried. Then what we have to do? So can I say we have to change the first queen position? Can I take here? Yes. Now try all possible combinations. Sir, I think now you got idea. You have to tell the answers. Sir, can I take second queen here?
No.
Can I take here?
No.
Can I
No.
take here?
No.
Can I take here?
Yeah.
Yes.
Now here third queen.
Yes.
Yes.
Now here can I take fourth queen?
No.
No.
Here,
No.
No.
here.
Yes.
Can I say is it one solution?
Yes.
Now tell me where first queen is placed. Can I say first queen is placed in second position, right?
Yes.
Second queen is placed in fourth position.
Yes.
Third queen is placed in first position.
Yes.
Fourth queen is placed in third position. Is it a solution 1 or not?
Yeah.
So is it, do you have any other solutions? Possibility is there, right?
Yes, possibility.
Yes, that's what called recursion. That's what called recursion. Now I will take the queen here. Is there any possible to place here?
No.
No. So fourth queen, there is no possibility. Now I am taking here third queen. No possible, right? Can I take here? No possibility. Can I take here? No possibility. So second queen possibility is also not there. Now you have to check first queen. Where we need to place first queen now? In third place.
Third.
Can I take here? Yes.
Yes.
Can I take here? No. Here? No. Here? No. Here we can take, right? So fourth queen, here we can't take. So here we can take. This is another combination. Can I say, is it another combination?
Yes, sir.
Yes. Can you tell me what is the position of first queen?
Means reverse of the first solution.
Yes. So third position. Then second queen is placed in first position. Third queen is placed in third position. Fourth position. Then fourth queen is placed in second position.
Second position.
I can say it is a second solution, right?
Yes.
Is there any
Yes.
possibility for third solution? Definitely. Let me check. Can I take here?
No.
No.
Can I take here?
No.
No.
No. So both the possibility combinations got completed. Here?
No.
No. Here we
No.
can't. Here we can't.
No.
So can I take first queen in fourth position?
Yeah.
Yes.
Yes.
Now take second queen here. Can I take?
Yes.
Yeah.
Can I take third queen here?
No.
Can
No.
I take here?
No. No.
No.
Can I take here?
Yes.
Yes.
Now fourth queen here.
No.
No.
Fourth queen here.
No.
Here.
No.
No.
Here.
No.
No.
So now can I take third queen here?
No.
So there is no possibility for fourth queen and third. Can I take second queen here?
Yes.
Yes.
Third queen here? No.
No.
Here
There is
also
no
we
possibility.
can't.
No.
Here also no. Here
No.
also no possibility.
No.
Can I take second queen here?
No.
No.
Second queen here?
No.
No.
No. Can I say these are the only these two solutions for this?
Yes.
Yes.
So whatever steps I have followed here, same thing we can convert it into the program, sir. That is called as backtracking. See, same concept is there even for Sudoku also. In Sudoku also, how you are going to solve? So if you see Sudoku solver, just a second, Sudoku solver. Yes, you can see it is
Yeah.
nothing but something like a 9 by 9 chessboard, something like this. 9 rows, 9 columns will be there. So in every row, in every column, and even in every grid, you have to take only one digit that should not be repeated. You can see just example in the first row, first column, we have 7. That 7 should not be repeated in the same row. That 7 should not be repeated in the same column. That 7 should not be repeated in the same grid. Like that we have to take. Some numbers are already given. You have to try for other combinations. Now, can you please tell me in this third position, which number I can take? Can I take 1, sir?
No.
No. Why? Because in the same row it is there, right?
Yes.
Can I take 2, sir?
No.
No.
No. Because in the same row it is there. Can I take
Yes.
3, sir?
No.
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 Because in the column it is there. Can I take 4, sir?
No.
No, because in the same grid it is
Yes.
there. Can I take 5, sir?
Yes.
Yes.
Can I take 6, sir?
Yes.
Can I
Yes.
take 7?
No.
No.
Can I take 7?
No.
No.
So 5 is allowed, 6 is allowed, 7 is not allowed, 8 is not allowed, 9 is also not allowed, right?
No.
Yes.
Yes.
So in this place we have 2 options, but we
But
can't
this-
check 2 options at a time, right? Are you getting my point?
Yes.
Yes, sir.
First we will take 5. Then we will go with the next cell. In the next cell, if any problem is coming, there is no possibility means we will come back. Previously, we have taken 5. That's why we have an issue. We will change that to 6. Getting?
Yes.
Is it
Yes.
backtracking or not?
Yeah.
Yes, sir.
Now, first I will try to take 5 here, because here itself it will show mistake whether your program is right or not. Just let me, because it is online tool, sir. Just I am trying to take 5. So there is no mistake. That means we can take 5. Now, what is the next combination, sir? Is it possible to take 1?
No.
No. 2? No. 3?
No.
Can I try for 3?
Yes.
Yes.
Yes. Yeah, we can take 3. Okay. And what are the combinations? Can we take 4?
Yes.
Yes. Can we take
Yes.
5?
No.
No.
No. 6?
No.
7?
No.
8?
Yes. No. No. No.
No.
No.
In the same row.
No.
9?
No.
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 So we have another 2 combinations. But among these 2, any one will be true. Now I will take 3. What will happen? Have you observed? It is a mistake. It is in wrong place. Are you getting?
Yeah.
Yes,
So
sir.
here correct number should be 4. So like that we have to trace, sir. This problem is called as Sudoku problem. This Sudoku and n queens will comes under recursion with backtracking. Okay. So my sincere request for you people, if you understood this recursion chapter, because anyway in our syllabus it is there. Once if you understand this recursion chapter, everything will become very easy for you, sir. Trust me, recursion chapter, don't keep any leave on that day. So you have to prepare with so many questions, and you can have a interaction session, and you have to learn this recursion very clearly. Then any kind of problem you can able to solve. Now, are you want to see the solution for this? How I implemented this executable code for this n queens? Do you want to see?
Yes.
Yes,
Yes.
sir.
Eagerly waiting.
Yes.
Yeah, I'm still confused how it will solve.
But don't worry, that code I won't copy paste and I won't execute in the regular class. I will explain with each and every terminology, every line, every pin to pin code I will explain. See, you can get one confident. I'm going to tell one simple story, sir. For explaining the problem statement, I will take 40 to 45 minutes time. But for writing the code, I'm going to take 20 minutes till I completed almost 7 batches. Okay, 7 batches. This is the 7th batch. In this n queens problem, we have 3 functions are there. The students are asking to repeat only one function. Only one function. Rest of the functions at the time of writing the code itself, they understood. So you can imagine how easy these concepts are and how beautifully we are going to project for you. Only one function. So they are asking for repetition. Sir, can you please repeat that function one more time? Like that, they will asking only one function. Rest of the code, they are not going to ask. So you can imagine how easy it is. But now don't ask for the explanation of the code. Now I am going to just, I will copy paste the code and I will explain how it will be. Okay. Just have a look once. N queens problem. This is nothing but what we have, the chessboard problem, sir. This is nothing but the chessboard problem what we have. So totally main method is there. Here we are going to fix what is the size of the chessboard, and we are calling n queens problem, and we are printing how many solutions are there. There are 3 functions. One is n queens problem, where we are going to check the solution is found or not. If solution is not found, we will pass all possible combinations, where we are using 2 main important tools. One is nothing but recursion, one is nothing but backtracking. And here, so is safe function will be there to check whether is it a safe location or not. I told the collision we have to check, right? That is the cases. And this is a display function. That's all. I will execute this code and I will show you. Really for that 4 by 4 chessboard, so is we are getting the same 2 solutions or not? I need to cross check. Java C, I am taking test.java. The code compiles fine, Java space test. Since we are talking about 4 by 4, how many solutions are there, sir? 2 solutions are there. Q represent the position and X represent empty values. Is it correct? You can see. So now, just now we have seen, right? One second. Where is that? Yeah. So second position, fourth position. Is it correct? Second position and fourth position. Then first and then 3. First and then 3. This is solution 1. In solution 2, so 3, 1, 4, 2. 3, 1, 4, 2. Two solutions we got. Sir, if I am taking 5 by 5 chessboard, what will happen? Nearly we are going to get 10 possible combinations, sir. 10 possible, because if you increase the rows and the columns, more possibilities we will get. If you take 8 by 8, I think around 50 or 60 cases you will get. 92 cases are there. See, is it possible to find out these 92 cases by ourselves? If you have a recursion, yes, we can able to do. Even it is not taking much time also. Just it is probabilities wise, it is checking, is there any possibility or not? Okay, how easy it is. Even we can try for 16 by 16 also. All possible combinations it will return. Let me try for 10 by 10. Even you can't imagine. So 724 solutions are there. So practically, is it possible for us to compute? Definitely not. But if you understand the trick on this, everything will become easy. Sir, same like we are going to see Sudoku puzzle also. Sudoku puzzle also we are going to, we will give the input with the zeros. It will give solution by filling that zeros. Okay. So hope you got some idea about what we are going to cover in our backtracking. Are you clear with this, friends? Please confirm.
Yes.
Yes,
Yes,
sir.
sir, clear.
Shaker, code is not understandable. At this stage, definitely it is not understandable. Once if we go to that concept, you will get clarity. Okay. Yeah, that's what I am telling. Shaker, you can't understand the code as of now. I will explain in my regular classes how it will be. Okay. Any doubts, friends, up to this?
No, sir.
No, sir.
Yeah, thank you, Shivashankar.
Doubt will doubt will come after classes.
You won't get, sir. Who is that? What is your name, sir? Tushar.
Tushar, sir. Yes, sir.
Yeah, you won't give this answer after completion of the class also.
Yeah,
Huh?
just hoping so.
Yeah, definitely. I will take one complete 1 hour time to explain that n queens problem, and some 30 to 40 minutes time to Sudoku problem. And I am planning to introduce one more problem based on this backtracking. It will be easy, sir. Not that much like you are going to think.
Yes, sir. Sure. Definitely.
Right. Yeah. So just I'm giving some information about our future plans. That's all. Beyond that, nothing. So now I think we are at the third unit. So first problem and the second problem. Is it clear, right? And meanwhile, I will add some concepts like this, sir, because it is a demo. If I am taking these programs in the demo, you people are going to feel like it is something like a programming session. Or if I am taking theory, you people are going to get bored. That's why, meanwhile, I am going to add the concepts from different topics. That doesn't mean that I'm going to stop explaining that concept here itself. That the continuity will be there, sir. Don't worry. Yeah, just with one small code, I will stop today's session because time is around 11. So what is a third code here is just I will give skeleton alone. What is a third code here is we have to implement a program to find maximum of two numbers. We need to read two numbers from the user and we have to calculate maximum. See in the main function, I'm going to ask the user to enter two numbers. So generally, if I want to read dynamic data from the user, we will always depending on scanner class. So system.out.println array user, can you please enter any two numbers? Any two numbers like this I am going to ask. How to read those two numbers? Let us call obj.nextInt for the first number, and the second number I'm going to store it in b variable. So like this I'm going to take. So total I'm going to implement finding of a maximum number, maximum of two numbers by using three algorithms, three steps, three methods. The first one is public static integer maximum of two numbers underscore version 2 or maximum underscore or maximum v1, which will take two numbers like a and b, which is going to return maximum. In this example, I am going to use if else concept. Okay, if else concept. If a value is greater than b, I will return a. So otherwise, I will return b. That's all. Even else is also not required. So if this condition is true, I am going to return a. Otherwise, I am going to return b. So now, can I call that function? Yes, system.out.println of. So maximum of two numbers by using version 1. So which function we have to take? Max 1 by passing a comma. That's all. Like this we have. So what is the second way, sir? Public static integer max version 2 I am taking, where it will take two numbers. I am going to use conditional operator. So what is this conditional operator? Simply I will check a condition like a greater than b. If this condition is true, I will return a. Okay, otherwise I am going to return b. That's all. Simple, sir. So what is the third one? Third function is also there. Public static integer. So main version 3, which will take two numbers. And do you know in Java, we have predefined method is there to find maximum. So just I am going to use that. Return math.max of, which will take two numbers like a comma. These are the three ways for finding maximum value. I am trying to execute these three ways. In these three ways, whether it is printing the same result or not, we have to check. Let me cross check, sir. I want to run this code. Is there any mistake in the code? No. Maximum, there is no.
For the message.
Yeah. So enter any two numbers. I am giving 10 and 20. What output we are expecting? In all these cases, we got a 20. Now assume same program I am giving 10 minus 20. What output we are getting? 10. So is the program is working fine or not? Yes, this is the small code how we can able to check maximum of two numbers. Are you clear with this application, sir? Please confirm.
Yes, sir.
Yes, sir.
Right. So this is nothing but what we have today's session. Remaining things anyway, some algorithms and some theoretical part. Even tomorrow, maybe I will explain the linked list, maybe one or two operations on linked list. Like today, I explained this backtracking, right? In the same style, I will explain that what you can call linked list related concept. Then I will continue. Okay. So hope you understood this today's session, right? Any doubts? Do you have any doubts up to this?
No, no. All clear.
Right. If you are having any queries, just you can feel free to ask. If everything is okay, tomorrow we will continue. I very thankful for you really, because 20 members are there in the session. Now time is around 11, 12. Okay. So really, I'm going to appreciate your interest towards this. Whether you are joining or not, forget about that. But attending in this time period, that is really good. Yeah, anyway, again I am repeating, so we won't take the class up to this much. So the demo classes only we are having at from 10 to 11, sir. But please make sure our regular class timings will be 9:15 to 10:30. Okay, 9:15 to 10:30. Yeah, thank you, sir. Good night, have a nice day. Tomorrow we will meet for the continuation.
Thank you, sir. Good night.
Right, good night.
Thank you, sir, for
Thank you.
session. Good night.
Yeah, thank you. Good night.